Today's lesson we'll be talking about sine and cosine curves. Now we've already kind of constructed the main sine and cosine curves in class. So here we're going to build off of that and add things. So we're going to add two things to our curves today, which are amplitude and vertical shift. But let's talk about what the sine curves look like. So the general equation should be y equals a sine kx and y equals a cosine kx, where k is going to be greater than 0, because we don't want to have a negative period, because that would go in on itself and that would not make sense. So having an amplitude is the absolute value of our a value. So if it's negative, it's just amplitude, let's go straight to there first so I can explain that, is going to be the measurement of sinusoids that describes the magnitude of the difference between the variable's extreme values. So on a graph, depending on like how high it gets from its mean, going from one point to the top to the bottom, use a different color here. So from that to that would be your a value. From there to there. And it's always going to be the absolute value because it also goes down. So we're kind of talking about a distance kind of value, so that's why it's the absolute value of a. And then period, which we'll talk about in the next video, is 2 pi over k. For right now, k will just be 1. Okay? So our periods will be a value of 2 pi for this video anyway. Okay. Now, an appropriate interval on which to graph one complete period, so one oscillation of your sine value, is from 0 to 2 pi over k, which will be, like I said, to 2 pi because our k value is going to be 1. Okay. The next value is a vertical shift, is the measurement of sinusoids that shifts the sinusoid all along the y-axis. So if I have a graph, and let's say this is my sine function, then your value may move it up, or it may move it down, depending on what that value is, but you're moving up and down on the y-axis, not the x-axis. Okay, so let's graph some. So here, graph the following functions. F of x is 3 plus cosine of x. So for this one, cosine of x, remember that's where you have the values of -1 for 0, 0 for pi over 2, 1, so on and so forth. Now, how I usually graph these, and I know that we didn't really do it in the last one, but I only graph like 4 or 5 values. Okay, we don't have to graph every single point, because that would take us forever. So we're going to use the values and our knowledge of the parent function of sine and cosine to help us graph it normally and get the correct curve. Okay, the first video was just to kind of get you to understand where the values are connecting from the unit circle. So here we're just going to graph the basic ones, the nice ones to graph basically. So if I plug in 0 to cosine, right there, then cosine of 0 is 1. And then here I need to add to 3. So 3 plus 1 gives me 4. Okay? So this one is showing a vertical shift. So we're not doing anything to the cosine, we're just moving the function up. So 0, 4 would be that first value. Pi over 2, cosine of pi over 2 is 0. 0 plus 3 is 3. Pi, or plugging pi in for cosine, so cosine of pi is -1, and -1 plus 3 is 2. Let me move that down. Okay. And then 3 pi over 2 plugged into cosine gives you 0 as well. So 0 plus 3 is 3. And then cosine of 2 pi is 1 again, plus 3 is 4. Okay, so then our graph will look something like this. So that's one period, or one complete period or oscillation of cosine, but we've shifted the graph up 3 values for each y value. Okay? Okay, and the next one, here now we'll mess with the amplitude and not the vertical shift. So we're going to multiply by -2. Now, this does two things. 2 amplifies all your y values and multiplies them by 2. The negative makes it flip over the x-axis. Okay? So when I plug in 0 into sine of 0 is 0, but then -2 times 0 is 0. Okay? Sine of pi over 2 is 1. So now instead of just being 1, you multiply it by -2, gives you -2. So it flipped down. Sine of pi is 0 again. So -2 times 0 is 0. And then sine of 3 pi over 2 is -1. But now -1 times -2 gets you +2. Cancels each other out for the negatives. And sine of 2 pi is 0 again, times -2 is 0. Okay? Now, if you don't understand where I'm getting these values from, remember it's always coming from the unit circle and my unit circle knowledge. So then plot those. Okay, and that would be my graph. Now, maybe one thing that kind of just dawned on me, you're probably wondering, how do you know that you need to use these values? Well, the reason I use those values is, one, those values produce nice values on your sine and cosine and basically all your other trig functions that we'll talk about in graph. Okay. Now, how I came up with those, okay, you want to take a normal period for your function. So for sine and cosine, normal period would be 2 pi. Okay? And I always take the normal period, or whatever period I have now. So when we change our period, this will change as well. But my period for these ones is 2 pi. And to get the nice values, I always divide my picture into fourths. Okay? And you always start with 0. So here, if I divide this into fourths, 2 pi over 4 reduces to pi over 2, right? So the increments in between, like the next points, are going to be pi over 2. So if you always start with 0, the next one you add a pi over 2. So it gets you pi over 2. Then you add up to pi over 2 to get pi, because pi over 2 plus pi over 2 gives you 2 pi over 2, which reduces to pi. Then I add another pi over 2, which is 3 pi over 2. Then I add another pi over 2 to get 2 pi. Okay? And so these values always kind of end up showing up, no matter what you do. So if our period changes, which we'll do in the next video, then these values will look different, but when you plug them into your function, you will always get your values that you plugged in to reduce because of what else is going on, down to these 5 values, which when you plug them into your sine, cosine, tangent, cotangent, secant, cosecant values, you will always get the same values that you got from the parent function. That's what's nifty about using these, okay? But that's kind of how I know that I want to use these, because they've got one nice numbers, plus it gives me a nice range of values so that I can get a decent picture of my graph. I don't do like the first 4 in the first quadrant. Like I don't use 0, pi over 6, pi over 4, pi over 3, and then pi over 2, because that would only get like a little bit of the picture, and you really wouldn't know, like just from looking at that, how to get to the next stuff. So this makes it easy to get easy numbers and a good picture of your sine and cosine, especially at the beginning. Okay, but that's kind of how I come about how I got those numbers. Okay, if you have any questions during class, I know this is a little confusing on why. I'll try to maybe explain it differently in class if you need me to. Okay, have fun.